Hey, readers, writers, and researchers, we started class this morning with a quick refresher about what is a producer. So you were able to get those gears turning this morning and to start refreshing some vocabulary as we move into research question 2. So let's recap. We're going to have a few new vocabulary words that we'll be dealing with for all of RQ2 this week, and actually a lot more of them for RQ3 next week as well. So what is a producer? Well, producers are living things that get their energy from the sun and make their own food through a process called photosynthesis. So plants. Producers are living things that get their energy from the sun and make their own food through a process called photosynthesis. So we're going to be talking about a word called adaptations as well, because as we get into RQ2, I'm going to be asking you, how does your producer adapt to get what it needs to survive? Or how has it adapted? What are its adaptations? Well, an adaptation is a feature that helps a plant or animal survive in its environment. So what are its roots doing? How have its leaves adapted? What does it look like? What shape has it taken? So an example of a consumer or animal adaptation is that the polar bear has small ears and a small tail, which minimizes the loss of heat in a cold environment. So this is another word we will be using regularly this week. One other word we'll be using regularly this week is nutrients. So nutrients are substances used by an organism to survive, grow, and reproduce. So how are our plants getting their food? So I may be asking you, what adaptations does a plant have to get the nutrients it needs to survive? How does the plant get its food? So those are a couple of words. I have added them to our ecosystems word wall. So remember, this is a word wall that you can access every day on Canvas. So the link is always at the top of the day. Click here to access our word wall. And we will be adding to this as the unit goes on. So today under plants, we've added producer, adaptation, and nutrients, because these are tier 3 words that are going to become part of our everyday language. So because they're here, you won't need to write them down. You always have access to that. Now, what are we doing with these words? Well, our goal for today is to research producers in our ecosystems and add to our research question 2 organizer. So research question 2 is all about producers. Who are the producers in your ecosystem, and what have they done? How have they adapted to get what they need to survive? So I'm going to be doing some modeling today. You'll be able to follow along in page 51, because that's where you'll be able to copy down my work. Remember, as I model, you never need to copy down work until I pause and tell you to write the work down. So you can get page 51 open, but you don't need to write anything until I ask us to pause and write. So let's take a look at RQ2 and what this will involve. How is the producer adapted to get what it needs from this ecosystem in terms of energy, water, nutrients, which we just went over? And then are there any other adaptations, things that don't have to do with energy, water, or nutrients? What does this producer give back to the ecosystem? And where did you get your evidence? So our goal is going to be researching 2, maybe 3 producers through the time this week. So I'm going to take a look at a book in EPIC, and I'm going to do some research on wetlands. Remember, you're keeping the same ecosystem. I'm moving around so I can demonstrate what it may look like for various ecosystems. So today I'm going to research the wetlands. Yours will stay the same. So here's the book that I found. I noticed I've got some nice text features like a table of contents here, and that really is going to help me tune in my focus as I'm researching today. So if you notice, chapter 3 says wetland plants. Right now, I'm just researching plants or producers, so I don't need these other sections. So I'm going to jump right to page 16. Let's give it a read. Read without interruptions first. Wetland plants. Wetlands can be grouped into 4 different types. Each type is based on its location, climate, plants, and soils. The 4 types of wetlands are marshes, swamps, fens, and bogs. Marshes are wetlands with soft-stemmed plants called emergent plants. Their roots are in the soil, but their stems grow above the water. Cattails, bulrushes, arrowheads, and water lilies are a few emergent plants. Marshes can be freshwater or saltwater. They can be inland or near the coast. Marshes receive most of their water from surface water, but groundwater may also feed marshes. Woody plants, such as trees and shrubs, grow in swamps. Swamps have standing water for at least part of the year. In forested swamps, trees such as bald cypress and red maple are common. These trees have bases that are buttressed or flared. This helps anchor the trees into soggy soils. The bald cypress has roots that grow vertically and stick out of the water. These roots are called knees. Scientists believe knees bring oxygen to the trees. Shrub swamps have shrubby plants such as buttonbush, willow, dogwood, and swamp rose. Forested and shrub swamps may be found beside each other. Peatlands. Before we move on to peatlands, we've got a photo and a caption here. Bald cypress roots or knees extend high out of the ground. They often stick out of the water when the ground is flooded. Peatlands. Fens and bogs are also known as peatlands. Peatlands are the most common form of wetland. Grasses, sedges, mosses, and wildflowers often grow in ferns. When plants in the fens die, they decay very slowly. This creates thick layers of peat. If too much peat builds up, it can cut off the fen's groundwater supply. This can turn the fen into a bog. Before I turn the page, we've got a call-out box here. Mangrove swamps. Mangrove swamps are wetlands found along tropical and subtropical ocean coasts. In the United States, mangrove swamps are found along the Gulf Coast from the tip of Florida to Texas. Salt-tolerant trees and shrubs grow in mangrove swamps. Red mangroves are known for their thick clusters of above-ground, arching roots. Black mangroves have spike-like roots that stick out of the ground. They supply oxygen to the plants growing in the water. Mangroves' root systems protect the coast from erosion during the storms. Bogs receive water and nutrients from precipitation only. This makes them nutrient poor. Sphagnum mosses does well in places without a lot of nutrients. It covers the ground like a spongy carpet. Sphagnum mosses creates a lot of acid. This limits what other plants and animals can live in bogs. Cranberries and blueberries grow well in bogs. Pitcher plants can also grow in bogs. They get nutrients by trapping and eating insects. Changes. Wetlands are always changing. Marshes can turn into swamps as trees grow in them. Swamps can flood and become marshes. Fens can turn into bogs as they form peat. In all types of wetlands, plants are the primary producers. They use the sun's energy to make their own food. This is called photosynthesis. Plants absorb the sun's energy and use it to change carbon dioxide and water into oxygen and sugar. When an animal eats a wetland plant, the energy transfers from the plant to the animal. The Florida Everglades. Humans can also change wetlands. In the Everglades, water once flowed from central Florida south to Lake Okeechobee. From there, it moves slowly through sawgrass marshes toward the Florida Bay. In some places, the water was only a few inches deep. An Everglades draining project began in 1905. It turned marshes into farmland. Today, people are working to restore the Everglades. It is one of the largest wetland restoration projects in the world. So we've got a lot of information in there. So what we need to do is focus in. What plant do I want to write down first? We only need to write down 2 or 3. So I would focus in on the plants that give you the most information in the books that you're reading. So for example, I saw a lot of good information about the bald cypress and red maple from this text. So that's going to be something that I write down first. So the first plant I'm going to research and get as much information out of this book as I can are trees. For example, red maple and the bald cypress. So I'm already going to go ahead and cite information, wetland ecosystems, page 8 to 19, because that's the section, I think that should say page 16 to 19, but that's the section that I'm retrieving this information from. So what will I grab? Oh, it should say 18 to 19. So there's a typo there. So 18 to 19. So let's look. Bald cypress and red maple. Well, here's something I found about them. They have bases that are buttressed or flared. This helps anchor trees into soggy soils. So think about mud. How is a tree going to stick in mud? Well, they flare their roots so that they can, or they flare their bases so that it anchors a little easier. So that is an adaptation that this plant has. I'm going to write that down over under, I'm going to write that down under the other category because it didn't necessarily talk about getting energy. That's more photosynthesis, right? It didn't talk about taking in water. It talked about anchoring to water. It didn't talk about nutrients. That's their food. So I'm going to say that's something other. It's just so that they don't fall over. Flared base anchors to soil. What I also found, it says they retrieve most of their water from surface water. Groundwater may feed marshes. Well, these are a plant in these marshes, so that's something I could write down. We've got that part already highlighted. The bald cypress has roots that grow vertically and stick out of the water. These roots are called knees. Scientists believe knees bring oxygen to the trees. So where can I put that? Well, in terms of water, we know we're getting our water from surface water or groundwater. In order to get nutrients, so now this is where it's talking about their roots a little bit. So we could also add this flared base anchors to the soil under other adaptations to get oxygen. We could say that it brings roots called knees. It's talking about those roots that stick up, bring oxygen to the trees. So that's something we could write down too. We could put this under energy as well. You're going to find as we're researching, there are a lot of pieces of information that could cross over one another. Is our goal to be 100% correct here? No, it's to read through our information about producers, right? Our main idea is that producers have adaptations they need to survive. All of our supporting details answer that question. So we're working to get that information in here. Now, before I let you research, I have a question for you. If I were researching the sphagnum moss from this page, so I've gone in, I've taken as much information as I can. I have some empty boxes under trees. That's okay. I can search on the internet tomorrow. We're going to focus on that. So I'm going to go ahead and move on while I'm still working within this book. So if I were researching sphagnum moss, what on this page may I write down? I'm going to pause, give you some time to search, and then we'll share. Excellent. So if I were researching the sphagnum moss, a lot of you pointed out this section. It says sphagnum moss does well in places without a lot of nutrients. It covers the ground like a spongy carpet. Sphagnum mosses creates a lot of acid. This limits what other plants and animals can live in bogs. So remember, our main idea is talking about who are the producers, how have they adapted to get what they need, and what we're doing is looking for information that answers those questions. So your turn. You are researching an ecosystem. This ecosystem will not be changing, so you want to take the same one that you have been researching for RQ1, and what you're going to do now is look for information about producers. So you're going to choose one book to start with from Epic or the ARC bookshelf, and we'll start reading this book and fill in as much information as you can about RQ2 producers. I'll pause the video here so we can go ahead and get started.